All right, chapter 3, day 6, still on inequalities. We are going to take those absolute value equations we were doing yesterday and now look at the inequalities. All right, so we have n is less than or equal to 3. So the absolute values alone, you'd solve it like it is. N is less than or equal to 3. But what that means is we want the distance from 0 to be less than or equal to 3. So then we could also go 3 the other direction, in the negative direction. So we have to do n and -3, but now since we're going the other way, we also have to flip the inequality. So you solve it like it is, but when you do the negative, you also have to flip your inequality. And then you have to decide which one it is. So there's a little thing. If it is a less than, you are going to make it an and. And if it's a greater than, then you make it a or. So you'll hear me say over and over again, less than and greater than or. This is a less than, so this would be a and. Because we would want, if we're going less than 3 away from 0, we could go up to 3, but we have to go less than 3, so we go back towards 0. And then we could go 3 to the left to -3, but we'd have to stay less than that, so we can go back to 0. So you can see how those less than, so since you're going less than 3 away, it makes an and, because you would be in between -3 and 3. So like here on this one, we have b is less than, absolute value of b is less than 8. So we do b is less than 8. We do b is greater than -8. Since the question was a less than, we would make this a and. So we want the numbers that are less than 8. So it'd have to be less than 8 and at the same time greater than -8. So it puts us in here. It makes an and because that distance has to be within 8, right? It has to be less than 8. So that less than and greater than or goes for all these problems we're going to do, right? So like here on number 3, this one is a greater than. Whoa, what happened with my pen? This one is a greater than. That is going to make an or. So we do -3x is greater than or equal to 3, like it's given, or -3x is less than or equal to -3. Because if your distance is going to be more than, let's say, 3 away, then you're going to be going to the outside. So we divide here by -3. I divided, so I have to flip. So x is less than or equal to -1, or divide by -3, divide by -3. I'd have x is greater than or equal to 1, right? The greater than makes an or, because then you could see you'd be at -1, including -1. You want the distance away to be greater than, which means you'd have to go further out, right? Which is going to make it an or. You have x is greater than or equal to 1, which means you could be at 1 including 1. It's greater than, because if you want to be greater than that away, you'd have to go further out, which makes it an or. So less than and, greater than or, right? So this next one is a greater than, so that's going to make an or, because you want your distance to be greater than whatever number you're talking about. So you need to keep moving further away. So we do 8 plus x greater than or equal to 9, or 8 plus x stays less than or equal to -9. So when you change the sign there on that second one, you also flip the inequality. So now to get rid of a +8, we subtract 8 on both sides. So we've got x is greater than or equal to 1, or subtract 8, x is less than or equal to -17. So it's an or, one or the other. So let's see, I'm counting by 2s. So 1 would be here, filled in to the right because it's greater than. X is less than or equal to -17. We'll be halfway between -16 and -18, and it's shaded in to the left. So less than and greater than or. Less than and greater than or. It happens for all of these compound inequalities that are made from absolute value inequalities. All right, so let's look at number 5. Number 5 is a less than, so that's going to be an and. I solve it like it is, so I have to do negative 3x plus 1 less than 7, and then still negative 3x plus 1. Flip the sign of the inequality and the number, so greater than negative 7. Solve them. To get rid of a plus 1, we subtract 1. So we're at negative 3x less than 6. Divide by negative 3. So I've got to flip, right? That causes a flip. So x is greater than negative 2. And when I subtract 1 from negative 7, this one's not going to be as pretty, is it? So I have negative 3x is greater than negative 8. I divide by negative 3, so that's going to cause a flip. So x is less than negative 8 over negative 3 would be 8/3. So it's an and. So I have my dot at negative 2, but I want to be greater than. And x is less than 8/3, so 8/3 would be what? 3 goes into 8 twice with 2 left over, so 2 2/3. So closer to 3 than to 2. I want to be less than 8/3. So I want to be between negative 2 and 8/3, which is at 2 2/3. You draw a line here to kind of separate this. I like made a line out of it. Weird. All right, so number 6 is a greater, so that's going to be a 4. Solve it like it is. N minus 7 is greater than or equal to 6. So then I have to do n minus 7 is less than or equal to negative 6. So then to move a minus 7, I would add 7. So I get n is greater than or equal to 13. Or, to get rid of a minus 7, I add 7. N is less than or equal to 1. It's an or. So I can be here or I can be there. So I can be at 13 solid to the right, or I can be at 1 solid to the left. Less than and greater than or. Less than and greater than or. Well, that line that was mysteriously made is now not going away. Guess you can hang out with us. All right, so remember, you can't break apart your inequalities until the inequality is alone. I'm sorry, absolute value. You cannot break apart the absolute value until the absolute value is alone. Like here on 7, I can see this absolute value is not alone because of the minus 8. So the first thing I would do to both sides is I would add 8. So then I have the absolute value of v over 9 is less than or equal to negative 7 plus 8 is 1. Now that the absolute value is alone, I break it apart. So less than and I've got v over 9 is less than or equal to 1. And v over 9 is greater than or equal to negative 1. So then to get rid of a divide by 9, we would multiply both sides by 9. So v is less than or equal to 9. And multiply both sides by 9. V is greater than or equal to negative 9. And it's an and, right? So both things have to be happening. So I could be at 9. So every tick mark is 2, 8, 10, 12. So 8, 9 would be right here between 8 and 10. Solid to the left, less than. But I don't get to go forever because I also have to be greater than or equal to negative 9. So negative 9, solid to the right. All right, number 8, absolute value is not alone yet, right? The absolute value is not alone because of this multiply by 7. So to get rid of the multiply by 7, we would divide both sides by 7. So then we're at the absolute value of x over 6 is less than or equal to 1. Now that the absolute value is alone, we break it apart. It's a less than, so it's an and. So I go x over 6 is less than or equal to 1. And x over 6 is greater than or equal to -1. To get rid of a divide by 6, we multiply by 6. So we get x is less than or equal to 1 times 6 is 6. And to get rid of multiply by 6, we divide by 6. So x is greater than or equal to -6. It's an and. So both of those things have to happen at the same time. So I want to be 6, including 6, going to the left, and at the same time, being -6, including -6, going to the right. So I want to be a number that's between -6 and 6, including both -6 and 6. So remember, absolute value inequalities, you have to break them apart into a compound. Less thans become ands, greater thans become ors.